Hey guys, my name is Ayushman, and today me and my team are going to deliver a series of presentation videos on the topic of serverless. Serverless is the new buzzword in town, which has been gaining a lot of attention from the pros and the rookies in the tech industry. But serverless is not just about the hype, it promises the possibility of ideal business implementations which sound quite pleasant to the ears and probably light on the budget. Expectations apart, serverless is really breaking ground in its part to disrupt your server infrastructure. Serverless is already used in production by companies like Netflix, Reuters, AOL, Telenor, etc. Industry-wide adoption is constantly increasing. Serverless is all set up to take up its own place, but don't expect serverless to conquer your infrastructure completely. There will be use cases where serverless might prove to be wrong choice. Your IT team has full access to a physical server 24/7, which is hosted on site or within a data center. The traditional server platform is generally managed and maintained by IT staff. This means you have got more control, allowing you to install and configure the software to your school's or university's specific need. Let's take the case study of Zalora, which is Asia's leading online fashion destination website. Zalora had a growth of about 100% year to year in the first 3 years and had to always chase down better hosting, faster loading time, and deployments took forever. So they decided to move their entire operation to the cloud. They wanted to build on the momentum that they had, and having a store hosted on traditional servers would require an effort of biblical proportions. This shows the value of 24/7 availability and making sure you won't have any downtime, which is tricky and requires a lot of fidgeting on the server side to ensure your server can and will scale gracefully the next time you have yourself a flash sale and your site gets assaulted by customers. Being on traditional servers, we have some main important responsibilities which we can get rid of while being on serverless. We get charged for keeping the server up, regardless of whether the server is serving a request or being idle. Secondly, we are responsible for maintaining the server uptime, its security, and its resources. Last but not the least, scaling up and down according to the application's usage. Now, traditionally, these would be handled by operations team or system admins or IT in the big companies. But what about smaller companies or individual developers? They need to do these parallelly while developing the actual application. So, what is serverless computing? Serverless computing refers to a model where the existence of servers is entirely abstracted away. Developers are relieved from the need to worry about low-level infrastructural and operational details such as scalability, high availability, infrastructure security, and other details. It is cost effective. You need to pay only for the exact time your actions run and the memory is used. It has low maintenance, which reduces the maintenance efforts to allow developers to quickly focus on developing code, which adds value. It's easy to scale as the cloud provider is responsible for executing your server code and dynamically allocating all the resources needed. It doesn't matter if you execute your code one time or 1000th time. So, do we know what these dolls are? I guess we all do that they are called the Russian dolls. And using them, we are going to present the whole architecture for a program. As we can see, that each doll represents each node of a complete program, like the infrastructure which contains the virtual machine, which existingly contains the packaging framework and the code later on. For a specific program to work, there are multiple requirements to be taken care of, like the code, obviously framework, packaging, container, virtual machine, and at last the infrastructure. But while using serverless, only the code needs to be taken care of. So when we talk about serverless computing, it does not refer to a specific technology. Instead, it refers to the concepts underlying the described model. Some promising solutions like Apache OpenWhisk have recently emerged that ease development approaches used in the serverless model. There are a lot of other serverless computing providers like AWS Lambda, Azure Functions. The serverless framework is an open source framework for building serverless applications. Using a simple manifest file, developers can define serverless functions, connect them to the event sources, and declare cloud services that are needed by their application. The framework handles deploying the serverless application to the cloud provider. It also allows developers to monitor services in production, roll out updates, and assist debugging issues. It also has a vibrant ecosystem of third-party plugins to extend the functionality of the framework. OpenWhisk is the technology that drives the serverless framework. So, what are the exact steps we need to keep in our mind while migrating to serverless? There are these 5 basic steps, which are identifying the problem, training the existing team, creating a proof of concept to verify the problem is solved. Fourth, optimizing the solution to take advantage of the cloud. Fifth, automate your continuous integration and continuous development pipeline. And finally, automate your testing. So now, what does serverless actually mean? Does it mean no servers? No. While serverless abstracts the infrastructure away from developers, servers are still involved in executing your code. Your code will be executed as individual functions. Your application needs to be broken into small functions. These functions will run inside stateless containers. No prior execution context is used to serve a request. A new instance of each function is invoked every time. Latency issue. Serverless functions will be running inside containers, so you will have to deal with some cold starts. A number of companies widely today are using the concept of serverless. Let's take the case of Netflix and how does Netflix do it. Publishers upload thousands of files to Netflix on a daily basis, and every bit of those files needs to be encoded and sorted before they end up being streamed to the user. Once the file gets uploaded, an event is triggered, which calls the function that splits the video into 5 minute chunks that get encoded into 60 different parallel streams that Netflix needs. Once the last part of the video gets processed, they get aggregated and deployed using a series of rules and events.